Hello everyone, I'm starting the second part of the lecture. This part is variables and primitive types. Okay. According to the syntax rules of Java, the most basic names are identifiers. So identifier is simply is a name set we are users programmer is putting, giving a name. For example, a class name, a variable name, this kind of names are called identifier. So identifiers can be used to name classes, variables, and subroutines, as I told you. An identifier is a sequence of one or more characters. It must begin with a letter or underscore that must consist entirely of letters, digits, and underscores. So this is the rule. So in an identifier, you can use underscore, letter, and numbers, but identifier can not be started by using a number. For example, this is not valid. Okay, this is not a valid identifier name. Or let's say again, you can't use like that. So, or so only these are all not valid. Okay. Um, so it can be it can be begin with a letter or underscore, and complete identifier is consist of letters, digits, and underscores. So these are, you can think separately. N can be an identifier, small n can be an identifier, rate can be an identifier, x15 can be an identifier, but you can't write, for example, um, this one, let's say, this is a special character, asterisk, so this is not valid as an identifier name. So let me to continue. Quite a long name is an identifier. It is separated by underscores. Hello world, this one is an identifier. But for example, this is not valid. Okay, this one is not valid. Or look here, it is written hello world. You can't write it like that. can put any space in between an identifier. If you have to put, you have to separate them with an underscore. Okay, you can do it like that or like that, and it is here. So I am thinking that you know it from previous courses. Okay, um, uppercase and lowercase letters are considered to be different. So hello with capital H and capital W, hello world, or all letters small, hello world, all capitals, hello world. This one are all different names. So if you give a name, uh, I'm giving this, but just want to um, make you to memorize. Um, Integer a, and then if you say a is 5, it will give a syntax error because this a is not declared and this a is not used. Because of not used, it is not given error, but it is given it gives you a warning. Okay, so so um, one thing more, while you are reading, I'm trying to make a summary. I'm trying to pick the important things, but um, if you feel that while you are reading, because I am also explaining and I am at the background um, saying something more. So if you feel that only underlined parts are not enough, read all of them because everything is connected there. Okay. Okay, when a name is made up of several words, such as hello world or interest rate, it is customary to capitalize each word except possibly the first. Think this is sometimes referred to as camel case. So um, I can say something like that. This can be an example of camel case. Okay. Or like this one, interest rate. It is a camel case. Of course, this one or this one is not given error, but it is a method to write the variable names. Okay. Things in Java can have compound names which consist of several simple names separated by periods, also called qualified names. You have already seen an example, system out println. The idea here is that things in Java can contain other things. Okay, a compound name is a kind of path to an item through one or more levels or containment. So This will give us many information about the system. Okay, so the system, the name system out println indicates that something called system uh, something called system contains something called out, which in turn contains something called println. So we will see them in more detail. Okay, uh, variables. Programs manipulate data that are stored in memory. In machine language, data can only be referred to by giving the numerical address. So, for example, let's say this is variable, let's say 0, x, 1, 2, 3. And let's say inside I'm keeping 5. Okay, so this address gives what? It is giving the location of the memory. Uh, so where the data is stored. But in high-level language such as Java, names are used instead of numbers to refer to data. So instead of this, we are using names. So that names are also refer that address. A name used in this way to refer to data stored in memory is called a variable, as you know. Variable is not a name for the data itself, but for a location in memory that can hold data. So it is not the name of the value, it is the name of the location. So that's why we are calling them variable. That location, value inside location can always change. Okay. A variable can refer to different data values at different times during the execution of the program, but it always refers to the same box. Okay. So it is same, exactly the same, the assignment statement in C or C++. So as you know, assignment statement from right to left. So I am just assuming that you know it and giving to the here 0.07 is assigning to rate. Here rate multiplied by principal, this result will be assigned to interest. As you know, this is a multiplication operator. It is an operator. Let me do it is these are operands. So operand 1, operand 1, operator operand 2. So rate and principal are operands. This multiplication operator, as I told you. Okay, so types. A variable in Java is designed to hold only one particular type of data. It can legally hold that type of data and no other. So each variable has a data type. The compiler will consider it to be a syntax error if you try to violate this rule by assigning a value of the wrong type of a variable. So we say that Java is a strongly typed language because it enforces this rule. So this is actually, okay, I will explain in the next part here what is strongly typed. Let's continue. There are 8 so-called primitive types built into Java. So these types are not objects or classes, because the other types are objects or classes. But here, these primitive types is regular types that we already know in other programming languages. They are byte, short, integer, long, float, double, char, and boolean. the first four, let me to use this one to be more clear. The first four hold integers, I mean whole numbers, 17, this number minus 0. The four integer types are distinguished by the ranges of integers they can hold. So the float and double types hold real numbers. So numbers with decimals. So these two, float and double, are distinguished by their range and accuracy. A variable of character holds a single character from the Unicode character set. What is Unicode? If you heard about ASCII code, actually you can think that the characters in our keyboards are written by using ASCII code. For example, 65 in decimal is A, capital A. 97 is small a, for example. And each character has a value in ASCII code. This ASCII code is 7-bit. Okay, what does it mean? It consists of 7 bits. So its maximum is if all ones are 1, it will be 255. So a number it's 7 bit, can be from 000, all zeros, to all ones. So what does it mean? It means a number can be at least 0, or if I calculate this, it is 6 digit. Okay, 2 to the power of 6 is 64. So I think it will be we get to number. So if it is 7 bit, it will be 127. Okay. This is in decimal, this is in binary. If it is 8 bit, for 8 bits, it means 8 digits. So it is from 0 to, if all of them are ones, it should be 255. So it means in 8 bits, there are 255 characters. And Unicode is 16 bits. So it is, sorry, not, it should be 256, 2 to the power of 8. So this Unicode is 2 to the power of 16. And this is the value of about 32,000 of something. Anyway, so this Unicode is this one. So this can hold about 32,000 different characters. Why they need it? Because in Turkish we have 29 characters. In English character there are 26. By combining the others, 255 is more than enough, I think. But not only that characters, there are other characters, special characters like Arabic, Chinese, and also other special characters that we are using. That's why they are using Unicode now. Okay. Boolean, it is holding true or false. The bit, byte, what is it? But here, byte is a data type that refers to a single byte of memory. A byte in computers, it is 8 bits. So, it is holding 8 bits of data, 8 zeros or ones. So there are 256 integers in that range. I can explain this one also, but it will take so much time. Let me to continue, because we don't have so much work with the numbers like that. Short corresponds 2 bytes, 16 bits, and as I told you, 16 bits are this much from 0 to 32,000. And okay, integer is 4 bytes, 32 bits, from minus this number to plus this number, and long corresponds to 8 bytes, 64 bits, and very big number. So why I am explaining you, according to your needs, you can use any of them. Okay. Float holds 4 bytes. For real numbers, as you know, we use it. It's it is about 10 to the power of 37, and it has at most 7 significant digits. So if your value is something like that, it will be rounded, okay, to this number. So if you are working with a program that you have to be more precise, you have to use double. So it takes 15 significant digits. So after the dot, you can use 15 significant digits. Okay. Also, a type character is same as short. It occupies 2 bytes of memory. It is just holding a character. Values of type char are closely related to integer values, since a character is actually stored as a 16-bit integer code number. Okay. Sorry about that, that I'm explaining this, but I have to. Okay, the other thing is literals. Okay, what is a literal? In a program, you represent constant values as literals. A literal is something that you can type in a program to represent a value. Okay, so constants in a program are literals. Simply, I can say. For example, to type a value of type char in a program, you must surround it with a pair of single quote marks, such as this one. Okay, if you are trying to mention character, you have to put that single quotes. Okay. The character and the quote marks make up a literal of type char. Without the quotes, A would be an identifier and asterisk would be a multiplication operator. So type may change in this case. Okay, this is how you can do it. You know it. So also certain special characters have special literals that use a backslash as an escape character. So if you remember to, while you are print in, for example, in Hello World program, where is it? Okay. here, if you need to print something like with, for example, double quotes, how you can do it? Program will think that you have to print. It is a part of the print. So here you can use escape characters. Okay. I go too much, I think. Okay. Still. Okay, here. So even this are two characters. When you put it into codes like that, program will assume that it is one character, \t or \r. But because of they are special, backslash is a special literal, or line feed, new line. So or single quote character. If you need to print single quote character, you can do it like that. What is it here? We are just, actually it is a little bit what I need to print. I need to print single quote. These are what? Not accepting same thing. Let's do it like that. This is codes that program understand that it is a character. And what is backslash? Backslash is escape character that when you use together with this code, program understand that you have to print code. Okay, you also know this from previous years. Okay, real numbers can be represented in an exponential form such as this one or this one. If you see E and something, a number, it means powers of 12, powers of 10. So 10 to the power of 12, or 10 to the power of minus 108. Okay, so this can be understood easily. So let me to write here also. I mean, on this one means okay, here there's a hint. Let me to say first, use always double. Don't use float, because double is have more numbers after the dot. It is allowing. Also, today's world is not like 20 years or 30 years ago. Each byte is so important, so If you doesn't matter if you use 8 bytes instead of 4 bytes. So, but if you need to use float, you have to append an F. Don't forget it. So, to the end of the number. So, um, if you declare it as float, let me to write float. Let's say it like that, x, and it is 1.2. This will give error. Why? Because when you write float, you have to append an F to the number that you wrote, this F. So it is sometimes maybe you forget to do it and try to understand what's going on. So using double is better. Okay. So ordinary integers such as this number and minus 32 are literals of type byte, short, or int, depending on their size. You can make a literal of type long by adding L as a suffix. So if you need to make a long integer, you can just as a suffix you can put L, like this one or this one. Also, Java allows binary, octal, and hexadecimal based literals. So actually, again, you know it, but let me to just shortly say binary numbers consist of zeros, ones, as you know, octal 0 to 7, hexadecimal is 0 to 15 actually, but we are using numbers after 9. So to explain these numbers, it is also some special characters. Okay. So if you are writing 045, it is a kind of octal number. If you're writing 0x, this is a kind of hexadecimal number. Okay. And also, binary literals start with 0b. Whatever it is. Okay. So these are some interesting points. Let's continue. Okay, this is something that I didn't hear before. As a final complication, numeric literals can include the underscore character. So you can use in numeric literals underscore character, which can be used to separate groups of digits. When you are using some number that it is very, very big, you can just group them according to your needs. and program will allow it. For example, the integer constant for 2 billion could be written like that, which is a good deal easier to be cheaper than this one. So it is easier to just read it. They put it, I think, by purpose. There's no rule about how many digits have to be in each group. So it is not like you have to group them 3 by 3 or something like that, according to your needs. So you can just use also same thing in binaries. So okay, for the type Boolean, there are precisely two literals, true and false. These literals are typed just as I have written them here, without codes, but they represent values, not variables. So we are not putting codes, but it is represent values. And as you know, we are using it in conditional expressions. Okay, here um, true value, if it is true value will be the value of test. Here, if rate is bigger than 0.005, it will give true to us. So actually we are using same thing. Okay. Still we have so much. Okay. I'm going to cut here and continue. I don't know if I talk too much or topics are too much. Let me to um, record this lecture and continue. I mean, just